Right, what we'll be doing here, I'm going to look at the first two required practicals for the AS, so making up a standard solution and then doing a titration on it. So the standard solution you're required to make up is sodium hydrogen sulfate. So we're going to be looking for a concentration about 0.1 molar. So the first thing to do there is to actually work out what mass of this you actually need to weigh out. So calculations should look something like that. So you've got your concentration that you want, the volume that you want, so we're going to look to make up about 250 cubic centimetres. Requires 0.025 moles, and then mass equals moles times MR lets us know what mass we actually need to weigh out. Now obviously a balance can't weigh out this exact mass because our balance doesn't have that many decimal places to it. So what I would need to do is when I've actually weighed out a mass close to that, kind of go back through the calculations and see what concentration I have actually made up. So first thing to start with, obviously board on there. I know I needed about 3 grams, so the balance is 2.37 currently, so obviously about 5.37 grams. Right, so overshot it a little bit. So record your mass of the boat and the solid. Next thing to do, pour it into there, reweigh the boat. Now the difference between what you recorded before and this is the amount of solid what you've actually added in there. That is the amount what you need to go back through the calculation with to work out the concentration that we are going to make up in here. Now the reason we've added it into a beaker so that we can add some water in there. We are going to be making it up to 250 cubic centimeters, so add about 150 in here. So reason it's in the beaker, beakers are nice and easy to mix together, so give it a good mix, make sure you get all of the solid actually dissolved. Right, from there we're going to make it up in the volumetric flask. So the volumetric flask is a more accurate piece of glassware than a beaker. This is why we don't make it up to 250 in here. Normally you could use a funnel on there, but I've got fairly steady hands. So I'm just going to pour and then just in case you've left anything in there, give the beaker a rinse with water. Right, so now to make it up to 250. So keep an eye on the actual line on the volumetric. Remember, bottom of your curve, the meniscus, should sit on that line. Hopefully I don't run out of water. Damn it. Voila, more water. Joys of live broadcasting. Say if you'd managed to screw up and squirted a lot more in and we overshot it like that, obviously the concentration in here is going to be messed up now. This is going to be more dilute than what you'd originally planned. So make sure the bottom of your curve there is actually sitting on the line. Ideally now you would start again, make it up fresh, but I'm just going to carry on since I'm showing you the method. Make sure you give it a good mix as well, so cap on, a few turns, get it all nicely mixed up. So that's our standard solution made. So key things, actually work out the mass what you should be weighing, record the board and the mass, then record the board itself. Difference between them is the mass that you've actually used. Into the beaker, some water in there, give it a mix, get it dissolved. From the beaker, transfer into the volumetric, make up to the mark with water. That is now our standard solution ready to use. So the standard solution we are going to use to work out the concentration of some sodium hydroxide here. So sodium hydroxide usually exists as these little pellets. You shouldn't typically handle them like this because what's happening now is it's absorbing moisture from my hand. It will actually be creating the sodium hydroxide solution on there, and the skin is going nice and gooey because it's dissolving, which is why you wear safety glasses, otherwise that happens to your eye. Alright, so we've got the sodium hydroxide, got some of it in here. First thing we need to do, however, is to actually fill up the burette. So, pretend that's clean. Make sure with your burette, tap as across so it's actually closed. The reason we are cleaning out with the sodium hydrogen sulfate rather than water, water would just dilute anything that's actually sitting in there. By adding the sodium hydrogen sulfate, clean it out with what you are going to fill up with, then any base in there that would react with this now gets neutralized by it. So you don't have to fill it all the way up to 50, that's just a waste of the actual chemical. Got a waste beaker here since I'm not next to the sink. Run a bit out. Twirl around, make sure everywhere on the burette has been cleaned. Now fill up the burette. And key thing to note, this area down here, run some out. Make sure you do not have an air bubble sitting there or an empty bit, because what you could do is open and close really fast. The sodium hydrogen sulfate would run down a little bit. It would drop at the actual burette. You would think you've added some, but in effect it's all stayed within there. So make sure you've got your solution in here as well. Also, you do not have to fill all the way up to the 0 mark, i.e. putting 50 cubic centimeters in there. If you were a little bit below it, that's fine. Some people faff on for far too long trying to get it done. Also, what I've seen some students doing, noticeably the BTEC ones, using a pipette to fill up a burette. That does not double the accuracy, it just makes me stand and laugh at you, so don't do that. Right, so we've got our sodium hydrogen sulfate in the burette, so now we are going to add our sodium hydroxide into the conical flask at the bottom. So I've got my sodium hydroxide here. Either pipette filler is perfectly fine, some people prefer the red one. Make sure you're gripping near the top, putting it on. It does not need to be forced on with a lot of strength. Also, do not carry by the actual pipette filler. Gravity, it will drop out, so carry around like this. Simply roll up, that will pull the solution up. Now I don't like these because the majority of them do get screwed up. The reason why, students fill in there with the solution and then they'll turn it upside down. The solution runs in there to the rubber and ends up dissolving, destroying it. You would need a tight rubber connection to actually fill that up properly. That sounded oddly sexual. Right, so I prefer the older ones. So holding air, squeezing your fist, that squeezes it out, and simply S to suck it up. Remember, meniscus on there, bottom of the curve, fill that up to 25. If your bulb caps out, simply press air, squeeze out more air, and you can continue going. So I much prefer these over the red ones. Nice and easy to fill up. And E empties a little bit out just in case you overshoot it. And then E transfer into the conical flask down here. Also, one thing I forgot to do, clean out the pipette with the actual solution as well. Forgot to do that on video. So clean out the pipette, you would suck up a bit of the sodium hydroxide, clean it out just like we did with the burette, twirl it round, get it to touch everywhere, pour it out. Again, anything that's in the pipette would react with the sodium hydroxide, and therefore when you're filling it up it would be nice and clean. Right, so we've got 25 cubic centimetres in here now. We need an indicator, a bit of phenolphthalein. When it says 2 drops, it is not being literal most of the time. Add a bit so that you can actually see the colour of it. So phenolphthalein, pink in basic conditions. It sometimes helps to have a white tile under here. So I'll just get a piece of white paper. Lift that up under there. Now we are ready to do the titration. So record where your burette is actually starting. You should record it to 2 decimal places. So for example, 1.00, 1.05, 1.10. That last decimal should always be a 0 or a 5. It ties in with the accuracy of the piece of equipment. It records to 0.05. Right, so once we've got this, open tap. Make sure you're swirling whilst you're doing it, so you've got some nice mixing going on. If, say, you pour down the side of the conical flask like that, you now have some sodium hydrogen sulfide sitting on, sodium hydrogen sulfate sitting on the side of the flask that you think you've added from the burette, but it has not gotten to the solution at the bottom and actually reacted with it. What you can do, bit of water, squirt down the side of the flask. The water is not changing the amount of moles in there. It's simply pushing the sodium hydrogen sulfate down into the solution at the bottom so that it can react with the sodium hydroxide. Right, so there we see it's gone colourless in the acidic condition, so it's just been neutralised there. Record your burette reading, again 2 decimal places. This is now your rough result. So the rough one will help give you an idea of roughly how much it took. So for me, just a little bit above 25. So you would work out the difference between your start reading, your end reading. That gives you your titra. From there, do some more titras. For a nice acid-base reaction like this, you should be looking to get concordant results where you have 2 or more titrations within 0.1 cubic centimetres of each other. From there, obviously you can just do a titration calculation and that will let you work out the actual concentration of the sodium hydroxide in here. And that's it for making up a solution and then doing a titration. Right, I'm just going to talk through the numbers since some people really aren't confident with this stuff. So, making the standard solution, as we said, I was making up 250 cubic centimetres of 0.1 molar solution. So where to start off? Well, we know what volume we want to make, we know what concentration, so we need to figure out how many moles that is. So concentration times volume, remember to convert your centimetre cubed into decimetre cubed, since that's moles per decimetre cubed, gives us 0.025 moles. So we need to work out how much mass of the material we actually need to contain 0.025 moles. So mass equals moles times MR, so moles times the MR. Like I said, the actual stuff in the bottle did have some water of crystallization, but I was just going to assume it's pure sodium hydrogen sulfate. So that's got an MR of 120.1. So we find out we need that mass. Now, we're not going to be able to weigh out that exact mass on the balance because our balance is just a 2 decimal place balance. So we need to weigh out just around 3 grams. So when I actually weighed it out there, the mass of the boat plus the sodium hydrogen sulfate was 5.50, and then when I tipped the actual solid material into the beaker to get it to dissolve, I reweighed the boat, found out it was 2.41 grams. So simple subtraction, 5.50 take away 2.41, 3.09 grams of material was used. So it should be clicking in your head, the fact that I've used more solid than I planned to, the concentration of the sample what I was going to make up is going to be a little bit more than the 0.1. So we'll kind of work backwards through the calculations now and work out what it actually was that I made up. And then just finishing off the calculations and going backwards through it, we know we had 3.09 grams of the solid material, so moles equals mass over MR, again the same MR. Keep all the digits in your calculator when you're doing this, that's what the ... is there, I just didn't bother to write up the full number. You can use fractions when you're going through if you want, it's more easy to be precise. And then obviously concentration, so rearranging the equation equals number of moles over volume, and that gives us an answer here. We do need to round this off to an appropriate number of significant figures, so we've got 3 significant figures there. That's 250 exactly, keep an eye on that point, so 250.0 if I was going to write it out, so the volumetric flask is precise. So the balance is kind of our limited one there, the 3 significant figures, so I'm going to round that off to 3 significant figures, and just remembering my unit there. So there's the concentration of the sodium hydrogen sulfate which I actually made up. And then we can go on to do the titration calculation with this. So once you've done the actual titration, you should end up with a table of results looking roughly like this. I mean, I've just made these up. As I was saying, you don't need to bother starting at 0. So I've came out, I've just roughly got around 25 there. As we can see, they're all concordant, they're all within 0.1 of each other. If I'd done a third one, ended up sort of rushing through and coming out like that, you would just ignore that result. You just look at your concordance for averaging them out. So the average there comes out as 24.96 recurring. Yeah. And the other thing what we need before we actually start into the calculations is a balanced equation. So we can see here the sodium hydrogen sulfate, sodium hydroxide, it's a 1-to-1 reaction. So you've got your proton which is going to be given off there, reacting with the hydroxide, straight up neutralization giving you the water, and your sodium is just going to act as the other counter ion to the sulfate, hence the sodium sulfate produced there. So now we'll look at working out the concentration of the sodium hydroxide. Right, so going through it now, there's different methods. You can lay it out like a table. I've done that in some of the other videos, but I'm just going to whiz through it here. So we had our average titer, we've worked out that it's a 1-to-1 reaction. So the moles of the sodium hydrogen sulfate, concentration times volume, concentration which worked out previously, and the volume, so the average titer from the titration there, we worked out is 24.96 recurring. So that calculation gets us this number. Now for the moles of sodium hydroxide, well, we know it's a 1-to-1 reaction, so if we've used up this many moles of the sodium hydrogen sulfate, it must have reacted with the same amount of moles of sodium hydroxide. So that number is also going to be here. And then once we know the moles of sodium hydroxide, if we want to work out the concentration, well, rearranging moles equals concentration times volume, we can get concentration equals moles over volume. So the moles, what we've worked out there, would also go in here. So the moles divided by the concentration, remember to convert your, the moles divided by the volume, remember to convert your 25 cm cubed that you pipetted into the bottom into decimeter cubed. And if you do that calculation, we end up with the same concentration. It should kind of make sense to you, because if it's a 1-to-1 reaction and we used up 25 cubic centimeters of, well, roughly 25 cubic centimeters of this to neutralize 25 cubic centimeters of this, and the concentrations are going to be pretty much on par as well. Right, so that's making up a solution, doing the titration, and the calculations involved. Thank you.